Okay, so now we'll be starting on the atomic structure, right? So for an atomic structure, you must first understand what are the components that makes up the atom. So the atom is generally the smallest particle of a substance, and there is three subatomic particles that is contained within an atom. They are number one, your protons, number two, your electrons, and number three, they are your neutrons. So all these are also known as subatomic particles, which are the different parts of the atom. So where are they found? Your protons and neutrons, they are generally found in the nucleus of the atom. Now what is nucleus? Nucleus is the one highlighted over here in the middle. Okay. Whereas your electron, they are found in your electron shell. So the electron shell is this other region surrounding the atom. Usually it has a orbital path. Okay, and what we can see is that for the charges of the proton, the proton are generally positive charge or +1 charge. Neutrons have no charge, so it's charge 0. Electrons are negatively charged. So what we can see is that the nucleus tends to be more positive. Why? Because when a positive add with a 0, you tend to be more positive. Electrons, because it surrounds the nucleus of the atom, it tends to be negatively charged. So this particular table is very important, which is commonly asked in exam. So please memorize it. One common thing is if you look at the mass for electron is then you can have either two numbers, 1/1840 or 1/1836. Either one is acceptable in exam. But the thing is, do take note that when you take 1 divided by 1836, right, you get a very small value. It's a 0.000 something. And this will indicate that electrons are very light. That means the mass they tend to be negligible. Okay, in the sense that they are not even considered as a mass. Protons and neutrons, on the other hand, they each have the same amount of mass of 1. Okay. Now, second thing you need to know that in an atom, right, the number of protons is the same as the number of electrons. Meaning, right, for every one positive charge, you have one negative charge. So they tend to neutralize each other in a neutral atom. And this would then indicate that they are electrically neutral. Why? Again, because of the negatively charged, the number of the negatively charged atom is the same as the number of positively charged protons. Okay? Now, one common way to actually write this out is that for the chemical symbol of an element, right, they actually have this indicated. Whereas for nucleon number, they tend to be right at the top and the proton number is at the bottom. Now what this means is that the nucleon number comes from the word nucleus. And what is found inside the nucleus is the number of protons plus the number of neutrons. Whereas proton number is just mainly your number of protons, which is the same as the number of electrons. So this is some of the information that you can actually obtain from the periodic table, from the element. However, nowadays the periodic table, right, they actually is not represented in this way. Instead, the mass number, okay, is represented at the bottom, which is the A, X, and then the proton number is located at the top. So sometimes it can be a particular, the name, specific name is at the bottom of the symbol. So do take note that in a periodic table, the arrangement is different. So this will indicate the proton number, and below the symbol is your mass number, or what we call the nucleon number. Okay. Is that clear? Okay, so this is the first main part of the different structures of the atom and elements. Next, we move on towards how do we go about writing the electronic configuration or electronic structure in an atom. In this case, right, the electron structure in an atom, right, really depends on the shell, the subshell, the electron shell, in which where they are actually arranged. So the one closest to the nucleus, right, is the first subshell. And in this case, right, the first subshell, which is the one in blue, okay, is represented by n equals to 1, meaning it's the first subshell. It will score a total maximum of 2 electrons. The second and third subshell will have a maximum of 8 electrons. Now, it's always ideal to have a complete filled subshell, which is either 2, 8, or 8. Why is this so? So that it is actually stable. Okay, so electrons must always fill the lowest energy shell first, which is n equals to 1. This is the lowest energy, and then this is the higher energy. Okay, and the arrangement is always in the form of 2, 8, 8. If you need the fourth one, right, it will also be 8. In your syllabus, the total the maximum number they can go is 20 electrons. Okay, they usually won't go more than that. The electronic structure is the arrangement of the electrons in the atom, and it can be represented either through drawing or written as like this. So what you can do is you want to show the electronic configuration of sodium. It has a total of 11 electrons. Okay, so what you can do is the first subshell will have 8, second subshell is 8, third subshell is 1. Total you must add, when you add them up together, you get 11. So this is how you go about checking. If you write a dot or comma, it doesn't matter, you still get the answer. Just remember to do the bracket to make it cleaner when you represent your answer. And one thing you will know is that the first subshell, the number of electron shell will tell you the number of electron shell, will tell you the period. Period means the horizontal rows of the periodic table, whereas the valence electron, in this case it is number 1, okay, the last electron shell, will actually indicate the group number. And what's this group number? It is mainly the column of the periodic table. Okay, so what we can see is over here, these are the different structures. You can actually draw it out. You will only be tested for the first 20. Do take note that from this, if you see it's 1 valence electron, this will be from group 1, and 2 it will be group 2, and 3, 4, 5, 6, 7, and over here is group 0. The difference is, if you look at this, helium is the only one that has 2 electrons in the outermost shell, but it's still complete. So this is the only exceptional case as compared to the rest. The number of periods is, if you count this as 4, this has 1 shell, so this is 1, period 1, period 2 because 2 shell, period 3 because there is 3 shell, and period 4 because there is 4 shell as per normal. So this is how you arrange them in the periodic table. Okay, so like what I shared, the valence electron on the outermost shell is where the furthest shell outside the nucleus, meaning, right, it has the lowest attraction force towards the nucleus. The nucleus is tentatively positive, whereas the electrons are actually negatively charged. So the further it is away from the nucleus, the lesser is the force, the attraction force. And we call these electrons in the outermost shell as the valence electron. Okay. So based on the number of electrons, because you tell the group number, right? So you are also able to see where it actually hits at, which is after group 3, it is known as the metal. And these are non-metal elements. Okay, so this is group if I put a group here, it will be 1, 2, 3, 4, 5, 6, 7, and group 0. So in terms of stability of the electronic configuration of noble gas, it must have the maximum number of electrons in the outermost shell, and this tends to be very stable and unreactive. So for having 2 electrons in the outermost shell, we call it a duplex electronic structure, whereas if you have 8 electrons in the outermost shell, you call it the octet. So octet means like octopus, so it has 8. Duplex because it comes from the word dupe, so it's 2. And this is only for outermost electron. So in the sense that all elements in group 0, they tend to be noble gases. What this means is that they are generally inert. Inert means unreactive. And they are monoatomic. Monoatomic means exist as one atom. Okay, so these are noble gases in group 0. Okay, next we will be discussing what is isotopes. So isotopes are generally elements with the same number of protons. However, they have different number of neutrons. Do remember to write another sentence is that isotopes are atoms of the same element with the same number of protons and same number of electrons but different number of neutrons. This one is more complete, and that the only difference is because due to the different number of neutrons, they will have different mass number as well, meaning the nucleon number will be different. So one example is isotopes of chlorine, where you can see that the number of protons is actually the same, both are 17. However, the mass number is different. One is 35, one is 37. And how do you determine that the number of neutrons that they have? You just take the number of neutrons equals to the nucleon number or the mass number minus away the proton number. Then you'll get the number of neutrons, in which over here you would see that it is 18 and 20 respectively. The number of protons and electrons, you see, they are same. Not that protons is what they have to be same between each other. Okay, so this is one good example. Now, what are some similarities and differences? So between isotopes is that they have the same number of protons and electrons, and because they have the same number of electrons, same electrons means same number of valence electrons, and therefore same chemical property. However, because they have different number of neutrons, they will have different physical properties. So from this, you will be able to tell that valence electron influences chemical properties, whereas different number of neutrons would then influence physical properties. Okay, so what are some physical property? You can be like density, melting boiling point, solubility, conducting of electricity, etc. But more towards density, anything that involves mass, melting boiling point as well. Okay. Okay, the next part we will actually be talking about ions. So